Talked about this laws of motion in the previous class. Today I have talked about the body diagrams and norms and not further. Let's wait for others and then. Okay, so yeah, we'll have the other people. So what we will do is that we'll start, right? And yeah, I will also go for quick iftar and then I will return back. So in the meanwhile, right, in the meanwhile, let me revise the portion that we have done. In the free body diagram, right, Nabil, in the free body diagram, what we have learned that if we have, let's say, a block, so on this block we have to, let's say, whatever forces are acting, let's say F1, F2, F3, F4. So on this block, whatever amount of forces are acting, so in the free body diagram, what do we do? We write all the forces which is acting on this thing externally. So we write separately we write each blocks, and then we have to count all the forces acting on that single block, and then we have to apply the second law in that one, right? So let's say that we have let's say we have this pulley system, right? Let's say we have this pulley system, and on this pulley there are two masses hanging, right? And let's say this one is 5 kg, and this one is let's say 3 kg. So due to this pulley, right, because this is hanging with this thread, so this thread will have tension in the opposite direction, right? This will have the tension in the opposite direction, and because this one is massive, so this will move in the downward direction. So this will have an acceleration which is downwards, this will have an acceleration which is upwards, right? This will have the gravity in the downward direction. So this is mg, and this will also have gravity in the downward direction. So what we will write is that we will have blocks for which we will write the free body diagram, right? So what would be the free body diagram for each blocks? So we have block 1, which is this one, and block 2, which is this one. Joined there. Yes, hello Alia. Assalamu alaikum. We have just started and we are talking about the free body diagrams, right? So we have two blocks, block 1 and block 2, and we have to write the free body diagram for all these blocks, right? So what would be the free body diagram for block 1? For block 1, right? We know that we have to apply the Newton's second law. So whenever the object is moving, then we apply the Newton's second law. Whenever the object is not moving, whenever the object is not moving, that is equilibrium, so then we have to apply the equilibrium condition, right? So for moving object, because this is accelerating, so for acceleration, we apply Newton's second law, right? And what does it say? So it states that sum of all the forces, this would be m. Okay, so I will come back in a moment because it is iftar time here, so I'll be back in a moment, right? Give me some minutes. So I'll be back in 5 minutes. Right. You guys just think about that. What would be the free body diagram for this block 1 and block 2? I'll be back in 5 minutes, right? Please wait a minute. Yes. Hello. Can you guys hear me? How much time did it take? So 5 minutes. Yeah. Can you guys hear me?
Yes, sir.
Okay. So now let us understand this part, and this is very, very crucial, right? So we have to write what is Newton's second law for this block one. So there is a sign convention that we have discussed earlier, right? So what would be positive and what would be negative? Which force would be positive? Which force would be negative? Yes, Talia, which force would be positive? Which force would be negative? So this is the acceleration. And tension is along the acceleration. So T would be positive, right? So this is T. And this mg, that would be negative. So this is mg, right? And this is mg. So this would be the first equation for block 1, right? And if you put the value of m, so this is t minus 5g, and this is 5b. So this is the Newton second, right? Similarly, we have for block 2. So for block 2, if we write the second law, so again the sum of forces, that would be F. So we see that acceleration is in the direction of mg. So mg would be, oh, so this is 3, right? So this is mass is 3 for block 1. So this is 3 and 3. Now we have this mg minus t, and this would be mg, right? So how much is this thing? This is 5g minus t, and that is 5a. So this is the second equation. So this is how we write the free body diagram of these kind of forms. So if it is clear, quickly note this thing down, and we do the question according to the right. So yeah, quickly note this thing down again, and then we'll talk about the other aspects. Yeah, whenever you have noted, just yes, noted.
Yes, sir.
Okay, so the next topic is friction, right? And we have yeah. So what we have studied in friction. So friction is directly proportional to this normal reaction, and it is right for static. It is mu s n, and this is for kinetic. This is mu k n. And Yes, what happened to this? Yes, when did I get disconnected?
So you started to say about friction.
Oh, oh, when I share my screen again and then yeah. So let me share my screen. Okay, so it's starting to wait, right? In the meanwhile, we can decide. So we have find friction one and the kinetic one, and both the frictions are dependent upon normal reaction, right? They are directly proportional to normal reaction, and the coefficient of static friction that is greater than the coefficient. So those things we know already. So yeah, this is green is loading. Let's wait for that. Uh, let's do this thing and then let's share this thing. Oh, what has that? Okay. So yeah, supposed to say good participant. One give them up. Again, I have just taken the earlier class and it was working fine and then please wait a moment. Okay, I was unmute and I was muted and then I was talking. Okay, so now let us yeah. So we have this static friction and we have this kinetic friction, right? And mu L is greater than mu K. So that is what I discussed. Now we have to understand this thing which is very important, and that is friction and inclined plane. So this thing is very important, and we have to understand. So we know that this thing is stationary. So what friction would be acting on this thing? Right? We have to write the free body diagram of this object. So firstly, we have to find out how many forces are acting on this thing. How many forces are acting on this thing? Can you tell me, Alia? How many forces are active? So let me write the yes. Yes. On this block, how many forces are active? Yes, don't hesitate, right? Whatever answer is coming into your mind, just tell.
Two.
Two forces. So what are the forces which are active? Yes, good. So two forces. What are the forces on this block which would be acting?
Gravitational force and frictional
Gravitation.
force.
Absolutely right. So gravity is there and then friction is there. But do we have any other force? Do we have any other force? So we have one more force, right? Because these are two surfaces, right? This is one surface, this is another surface. So due to that, we have a normal reaction, right? So the third force which is acting on this thing is normal reaction, right? So normal reaction is also there. So now let us write all the forces, right? So first is gravity, and that is downwards. This is mg, and then we have to write the two components of mg. So whenever we have this inclined plane, right? Whenever the inclined plane, so you guys have to remember that this is not x and y axis. This is not you take the x and y axis, right? So you take your x and y axis like this. So this is your x and this is your y axis. So this is your x axis, this is your y axis. So this is not in the y axis. Your x and y axis are like this. So let me draw that right. So the x and y axis are like this. So this is your x, not x but y, and this is your x-axis. Right? So this is your x-axis, this is your y-axis. Now we have this mg, right? We have this mg, and we know that. Oh, where did this pencil? Yeah. So we know that this angle is theta, and we have studied the resolution of vectors. So if this is mg, so for theta part, whatever component is with theta part, so what is this component called? What is this component? What would be this component? If this is theta, so what would be this component? Yes. So with this theta, you have mg cos theta. And this in this so in this part, right, this part would be your mg sin theta. So these are the two things that happen. So these are components of mg. Now in y direction, you have normal reaction, right? So this is normal reaction, and because this thing will try to slide down, but this is stationary. which means that some force is working against the motion. So that for motion would be this thing. This is your friction, right? And this is because this is not moving stationary, so this would be static friction, right? So you have forces, this one, this one, and this one. These are the three forces. But this mg will have two components, right? And because these are at equilibrium, so all the forces are balancing, right? So at equilibrium, all the forces are balancing, right? So first is the vertical part, right? First is the vertical part. What is the vertical part? You have n, that would be mg cos theta, right? And what would be the horizontal part? Can you guys tell me? What is the horizontal part? What is the horizontal part, guys? What is the horizontal equilibrium? How the x part is balanced? Yes, guys, please tell me. Yeah, so the horizontal part is balanced by this Fs, and this is mg sine theta. So this one is balancing this left. So this is your horizontal part, right? And now we can write, because we know that Fs is how much? Fs is mu Sn, right? So we can write Fs as mu Sn. So we can write this Fs as mu Sn, and this is mg sine theta. And now we know that what is this n that we have found now. So n is mg cos theta, so we can put that value. So mg and mg cancels, and mu s is simply tan theta. So that is the coefficient of static friction in the inclined plane when the inclined plane or the block is not moving. So this is how we calculate this thing. Is this part clear, guys? Is this part clear? Yes, is this part clear? Okay, so if it is clear, then yeah, let's move on to the other part. So we have taken that this thing is not moving. This block is not moving. But let's say that this block starts to move, right? So the block has started to move, then what will happen? So the second case is that block is moving. Block is moving in the inclined plane. Right. So then what will happen? So we have this block, and this block is moving. Let's say this is moving in this direction. This direction has acceleration. Now we will write the other component. So this is mg, this is theta. So this will be mg cos theta. This part is mg sin theta. This is normal. And then because this thing is moving in this direction, so friction will be in this direction. And this is Fk, right? Because this thing is so then if we write because this object is not moving in the vertical direction, right? This is not moving in upward, downward direction. So in vertical part, we have equilibrium. In vertical part, we have equilibrium. Right. What is this equilibrium? So the upward force that would be equal to downward force. So N would be mg cos theta. Now in the horizontal part, because in the horizontal part, this object is moving in downward direction. So horizontal part we will apply in horizontal part. We will apply Newton's second law. So we will apply second law. That because we have to write sum of all the forces, that is MA. So what would be positive and what would be negative in the horizontal part? Can you guys tell me? What would be the horizontal part? Second law. Can you guys tell me? Look at the diagram and tell me what would be the horizontal part. Yes. Yeah. What do you guys think? Please tell me what are the because I don't have to clear my doubt, right? You guys have your doubts, so please clear doubts in the class, right? So if these doubts persist in the examination on, then it would be a problem. Right? So please, if you guys have any confusion, please tell me. If you don't react, if you don't respond, then I would not be able to understand, right? Please tell me if these things are clear, and if you know, then please tell the answer, right? So don't keep the answer to yourself. So the force in the direction of acceleration, mg sine theta is there. So that would be positive. This would be mg sine theta. And then we have fk, which is in the opposite direction. So this would be f. And this would be equal to ma. So this is the second equation. Right. This is the first equation. And this is the second equation. And if we put the value of, if we put the value of fk in here, so fk would be how much? This is mg sine theta minus mu k, and this is n, and this is mp. And we already know that what is the value of n from this equilibrium condition. So we know that if you put that value, so that would be mu k and mg cos theta. So this would be the equation that we need to solve. M will cancel and we'll get mu k. Right, we'll get mu k is this one. So this was the idea of inclined plane and the object is moving. And then the concept that we need to understand in this chapter is So the next concept is this one. So that is pseudo force, right? Why do we apply or why do we need this pseudo force? So the laws of motion, they are applicable for what kind of frames? Do you guys remember that? For what kind of frames these laws of motion are applicable? Yes. Okay, so if you don't remember, then just remember that laws of motion are applicable only for the inertial frames. And what are the inertial frames? The frames which are not accelerating. So when then we can apply F equals to ma, and then all the other things, action equals to reaction. All these things we can only apply if the frame is not accelerating. Whenever the flame is accelerating, to make the laws of motion consistent, we use the idea of pseudo force, right? So how we can apply this pseudo force? So let's say, yeah, so we have these two kind of flames, right? Inertial flame, they are not accelerating, and non-inertial frame, they are accelerating. So in this one, all Newton's laws are valid, but in this one, Newton's laws are not valid, and we need pseudo force, right? So how do we apply this pseudo force? So let's say we have this lift, and this is accelerating upwards, right? Or let's say that you are in a lift, and the lift is going downwards with acceleration. So you guys will feel that you guys are light. So that phenomenon is called weightlessness, and that is due to these pseudo forces, right? So whenever the frame is accelerating, then we apply the pseudo force. So let's say we have this lift, right? And in this lift, this is accelerating upwards. So whenever we are talking about the motion of the object inside this lift, right? So for the object which is inside the lift, then we will have this pseudo force, right? So what would be the pseudo force? So for this person inside this thing, so F pseudo would be downwards, right? So for the purpose, a person in, if we write the Newton's laws of motion, so this is the person, and it will experience the acceleration downwards, and it will have some normal reaction, right? And then it will have some what is this thing mg. So if we write a function of f equal to ma, right, so this would be how much? This would be f is mg minus m, and this would be m. So this is right. Okay, but this object is not moving, right? So this would be zero. Yeah. So yeah, this is zero. And we will write not acceleration, but we will write f pseudo, right? So we will write f pseudo. So that will take in against the direction of acceleration. So lift is going upwards, so we'll take the pseudo force downwards. So this would be the free body diagram of the pseudo force. And this would be equal to how much? Because the object is not moving, so this is at stationary, so n would be mg plus f pseudo is ma. That is the thing that we have to take. So you see that normal reaction is not simply mg, right? This is ma plus mg. So that is that we have to take, right? Pseudo force, and yeah, this is the only thing that we need. And the last one that we will need is so now we'll do some questions, and then we'll understand all these things, right? Okay, so then we have this circular motion that things, and then we have this banking of road. So in banking of road, in your NCRT, what you guys have learned, right? So there are two scenarios in banking of roads, right? And there are right. So what is the slip velocity? So maximum velocity without slipping that you can move in the circular direction, right? So you guys have learned that. Yeah. So first case is the unbanked road, right? So first case is unbanked road. All these things guys have learned. Always just recapping these things, right? So what is the idea of unbanked road? So let's say you have this cyclist. This cyclist is moving in, and then this is a torque. So because this is moving in circular orbit, so there would be a force of accelerate towards this direction. And the centripetal force, right? That would be the centripetal force. And we know that because we don't want this cycle or whatever this car to slip in this direction, right? So this would be slipping. And if it is not slipping, right, then there would be some force which is acting in this direction, which is preventing the slipping. And that force is called the frictional force. So this is the frictional force. And you guys can see that this frictional force is similar to the centripetal force. So in this case, and let's say that its normal reaction is N, and then this is M, right? So then this frictional force would be how much? This frictional force is equal to it. So this is how much? This Fc is mv square by r, and this is F, which is mu s, and n, and that is mg, right? Mu s n Yes, guys, I got disconnected. What is happening to this internet? Okay, so at what point did I get disconnected? Can you guys tell me? At what point I got disconnected? Yes. At what point I got disconnected? Can you guys tell me? This has frozen, right? Why? Yes, can you guys hear? Yeah, can you guys hear me?
Yes, sir.
Okay, so yeah, my screen is loading. At what point did I get disconnected? So I was talking about this banked and unbanked, right? So let's quickly. I will just I will just write the result, and you guys have to just remember this thing, right? So in the unbanked road, where in which this road is not with some angle, then this is the maximum speed with which the bicycle or the cycle rider has to move, so that he is not slipping, right? So this mu s RG we have to remember. And for the banked road, so I will just write, I will just show you this, right? So I will not derive because that will take time. So I will just give you guys this final result. In the banked road, right, this is the velocity. So velocity is root rg mu s plus tan theta minus 1 minus tan theta, right? So this is the speed, maximum speed with which the car has to move in the banked road. So what is the banked road? So the road would be making some angle like this one, right? So this is the banked road. And in this kind of road, you have to remember that, so we have that maximum speed is this thing. So this result, just note down this part. And then there is this optimum velocity. So in the bank, this is the maximum velocity with which the car has to move. And then this is the optimum velocity with which the car has to move to save the tire from wear and tear. So that is the part. Right, this is the optimum velocity, this is the maximum velocity with which the car has to move without slipping. So just note down these two things, and then that would be all. Just note down these. Whenever you have noted, just tell me. Yes, noted. So this is the velocity in which you don't have any friction. This is called the optimum velocity. And this is the maximum velocity with which the car has to move without slipping. These two are different things, right? Okay, so now we have understood every topic. Then there is this vertical motion in vertical circle as well. So that part we'll talk about, right? When we get some question, then we'll talk about these things. So yeah, and in the vertical circle, you guys have to remember, right? So this thing you also have learned in your CBSE part. So I will just directly write the result that in vertical circle, right? This part has velocity VA, which is root of 5 GR. This part has a velocity which is VB, and this is simply root of 3 GR. And this part has a velocity VC, which is root, remember, in vertical cycle. So this is called vertical cycle. Okay, so remember these things. Now we can solve all the questions, right? So now let us solve all these questions. So let's solve this one, right? So first one is that a block of mass m rests on a horizontal table. A lightning magnetic passes through a frictionless pulley at the edge of table. From its other end, another block B of mass m2 is suspended. The coefficient of kinetic friction between the block and the table is mu, and when the block is sliding on the table, the tension in the string is. Right, so we have to find out the tension in the string. And so these are this one was the tough one, but let's start with the simple simplest one. Right. So yeah, these questions are simpler. So what? Yeah. So let's start with the simple question. Oh, so this was the question, right? So let's start with simple question, and then we'll put tough question, right? So first thing is that the mass of this thing is given, that is 20 kg. You know the coefficient of limiting friction, you know the coefficient of kinetic friction, right? So then you guys have to find out force of limiting friction or static friction, force of kinetic friction, and then acceleration and static friction if applied force is 20 Newton. Acceleration and kinetic friction if applied force is 100 Newton, right? So then you have to find out. Yeah, so this is the first question. So in the first part, you guys to find out what is the limiting friction. What is FL? This is the first thing that you have to know. So for that, what is this FL? So that would be simply mu L and N. And how much is mu L or mu S? So mu S is 0.4, right? And N is mg. So this is 0.4, and m is how much? That is 20, and then d is 10. So how much is this? This is 8, and 8 into 10 is 80. So 80 Newton, right? So if you want to move this thing, how much force you need to apply? How much force you need to apply? Yes, guys, if you want to move this block, then how much you have to apply. So Fk is simply unit and N. So this is UK and mg, and this is 0.3 into what you have to do is yeah. So this is 0.3, and then we have m, which is 20, and then this is 10. So this is 20 into 3, so that is 16, right? So kinetic friction is 60 Newton, and this is 80 Newton. So we can see that which was greater. Now we want to find out. Now we want to find out acceleration and static friction if applied force is 20 Newton. So you guys please find out what is the static friction if applied force is 20 Newton. Please guys find this one out. Yes, everyone, please find this one out. Yes, what is uh, what is the static friction and what is the acceleration? So remember, what is the key difference between static friction and limiting friction? Static friction is adjustable. Whatever amount of force you apply, so the opposite amount of force will be applied. So let's say if you apply 20 Newton force, so the static friction would be 20. If you apply 30 Newton, so static friction would be 30 Newton. Right? But this limiting friction is the static friction at the highest value. So this is static friction max. This is the only difference between limiting friction and static friction, right? So we know that we have limiting friction is 80 Newton. So if we apply the force which is less than that, so object will not move, right? So this third part, acceleration would be zero because the object is not moving, and then the static friction would be equal to 20 Newton, right? So Fs, this would be 220. Now the fourth part. So the fourth part is that acceleration and static friction if applied force is 100 Newton, right? So now you see that the force applied is 100 Newton. So now there would be no static friction, right? So the static friction will change into kinetic friction. So the acceleration would be how much? We have this thing with this block, and this is the force which is applied. So the applied force is 100 Newton. We know that there would be some kinetic friction, right? And because this is accelerating towards this direction, so this is the acceleration, right? And if we write, and then we have this normal reaction, and then we have this gravity. So we know that N is mg, that is balanced, but we have to apply the Newton's second law. Right, in here we have to apply Newton's second law, so summation of F, that would be ma. So we have this F, which is 100 Newton, which is in the direction. So 100 minus this Fk. Fk we have already calculated, that is 60 Newton. Mass is how much? 20. And then we have this A. So A would be how much? A would be 40. And this would be 2 meter per second. So that is how we solve these kind of questions, right? Is it clear, guys? Is the idea of this static and limiting and all this kinetic friction clear? Is this thing clear? Yes, Alia and Nabil, is this thing clear? Please ask me if you guys have any doubts, right? Please ask me if this thing is clear. Yes, guys, is it clear?
Yes, sir.
Okay, so then we'll move on to the next one. So now let's do some questions from these concept. So we have understood the idea of static friction. Now we will get these questions. So let's start. Yeah, these questions. Let's solve these questions. So now we have understood all the concepts, right? So now we'll solve all these questions. Why this? What is happening to this thing? Yeah, so now let's do this first question. So two bodies of 4 kg and 6 kg are tied to the ends of a massless string. The string passes over who got disconnected. So yeah. So we have two objects which are hanging with this pulley. So we have this pulley and two objects are hanging. Right. And then this one is 6 kg. This one is 4 kg. So we have the gravity in this one 6g We have the gravity in this one, which is 4g. Because this is 6 kg, this one is heavier, so acceleration would be in here. And the tension is in the upward direction. Tension is upward direction. This one is going because this one is going downwards, so this is going upwards. Right. So we have two blocks, one and two. And what we need to find out, the acceleration of the system in terms of acceleration due to gravity is right. So I will directly write in part one. So in part one, what would be the Newton's second law? Summation of F is ma, and in part one you see that tension is along the direction minus 4g, and that is 4a. So this is the first equation, right? And then you have in the second part, what do you have? So again, summation of F, that is ma. So F, this is going along 6g. So 6g minus t, that is equal to how much? So that would be your 6a. Right? Is this are these two equations clear, Alia? Are these two equations clear?
Yes, sir.
Okay, so now we have to find out acceleration. So what we will do with these two equations? What should we do that we can get the acceleration? So what should we do? Can you tell me? What should we do that we get the acceleration?
Sir, your voice is cracking.
Oh, my voice is cracking. So why didn't you tell me sooner, right? Let me check that what is happening with my voice. So microphone and speaker. Okay, this one is yeah. So this one is good. And then we have this. We have this optimize video time, loading controls, hide video file, direction. Okay, so how is my voice now? Is it clear now, or still breaking?
It's better, sir.
Okay, so I was asking that what should we do so that we can get acceleration. So we'll add these two equations, right? If we add, so t minus t, that will cancel. So adding these two equations, what we will get? T minus 4g plus 6g minus t, that is 4a plus 6a, that is 10a. So t and t cancels. This is 2g, that is 10a. So a would be 2g by 10, which is g by 5. So g by 5 would be the answer. Right, where do we have g by 5? So this b would be the answer. Is it clear? If it is clear, quickly note this thing down. Quickly note this thing down. And whenever you have noted, just tell. Please tell me whenever you have.
Thank you.
Done. Okay, so now let us do the second question, right? So let's do the second question. So what does this second question say? So we have this inclined plane, right? And we have this block. Now this because this block is put on this inclined plane, and for this block, this is the reference. This inclined plane is the reference. But now what we are doing is that we are moving this block itself. So then what is the idea that we have to use? Because the frame is accelerating. So then what is the idea that we have to use? We have to use the idea of pseudo force, right? And we have seen that what is F pseudo? F pseudo is simply mass into acceleration the other side. So this is the mass which we are observing. So the mass of the block, right? And if we consider this F pseudo, then we'll recover this acceleration, right? So because acceleration is right hand side, so F pseudo, this would be in this direction. That is F pseudo, right? And we know that what is this mg, and then we have this normal, right? So what we will consider is that we'll consider this thing as x and y axis, right? So this is our x and y axis. So this is x and this is y. Now we know that how much is this angle, right? So this angle is theta. So this angle would be theta, right? This is angle theta. So the normal component will have two components, right? The normal will have two components. And what would be that? So this is n cos theta, and this one is n sin theta. Is it clear? Is it clear?
Yes, sir.
Okay. Now a block M is based on smoothing dynamics and showing figure the which is given acceleration, the relation between A and theta for the block to remain stationary. So this block is not moving, which means that this force is balanced by this force, right? So the vertical part, from vertical part, what we will get? From vertical part, we will have this force n sine theta, that is mg, right? So, and then from the horizontal part, what is f pseudo? So f pseudo, this would be n cos theta, right? And okay, did I make a mistake in here? So if this is theta, right? If this is, okay, so this is theta, right? So this should be, yeah, this is correct. So if I draw this thing in here and this thing, this is theta, so this should be theta, right? But I should get, okay, yeah, mt, but so t cot theta. Okay, there is some problem in this right? So if I have this block, right, and this is, so this is This is yeah. So this is theta. This would be 90 minus theta, right? This would be 90 minus theta. This is theta. This would be 90 minus theta, and then this is theta. Yeah, so this is the correction. This is not theta, but this is 90 minus theta. So the angle is, then we have to correct this. So this angle is theta. If this is theta, then everything changes, right? So then this becomes, so all these things are changed, right? So we have to make the correction. So if this is theta, then this component would be how much? This is n cos theta. And this component would be n sine theta, right? So then what do we have? Then n cos theta from vertical part, n cos theta, that is mg. And from horizontal part, f pseudo, that is n sine theta. And how much is f pseudo? That we know already. So f pseudo is mass of this block, and then a, and this is n sine theta. So we know that what is this n? We can calculate from here. N is mg by cos theta. And then this is sine theta. So m and m cancel, and a is g tan theta. So that would be the correct answer. So if we don't figure out the angles correctly, then we'll get a different answer, right? So I was getting g cot theta, but that is not in the option. So I have to check the angle, right? So I already know that this is theta, and these are perpendicular. So this would be 90 minus theta, and these are also perpendicular. So if this is 90 minus theta, this is theta, and then these are also perpendicular. So this is 90 minus theta, so this is theta. And then similarly, we found out that this would be theta, right? Then yeah, doing these things, we get the acceleration as g tan theta. So is it clear? How do we use this pseudo? Is this part clear? Yes, is it clear?
Yes, sir.
Okay, then please note down this part, right? Please note down this part, and yeah, this diagram is important, right? So this diagram is important. If we understand this diagram, then the question becomes. So just yeah, just note down this part. Whenever you have noted, just take. Yes, whenever you have noted, please take. Yeah. Okay, so now let's do this next question, which is right. Okay, so now let's three blocks A, B, and C. Right, we have the surface, and 3 blocks. So A, B, and C, 3 blocks are placed, and one force is applied in this direction, and that is how much? 14 Newton. So 14 Newton is force is applied. Then all these three would move together. So they will have same acceleration, right? That is the idea. So the total mass of this thing, right? The total mass of this thing would be how much? That would be because A is 4 kg, this is 2 kg, and this is 1 kg. So total mass is 7 kg. Then the force is 14 Newton. So we can find out what is the acceleration. That is 14 by 7, that is 2 meter per second square. So this thing we know, right? Now the question is that then the contact force between A and B is. So what is the contact force between A and B? That is the thing that we have to calculate. So let's find out what would the contact force. So we have this thing, right? And this is B, and then this is C. So we know that this B is applying some force. B is applying some force in this direction, right? And then this is or this A is applying the same contact force. So this is the contact force due to B, and then the same force is applied in this due to B A is that is in this direction. Force due to B, both these are equal, right? And we also know that what is the acceleration with which this A particle is moving. So the acceleration of this A particle, this is A, this is in this direction. This is acceleration. This is the contact force. And we know that the force 14 Newton is applied to this thing, right? So 14 Newton is force is applied in this direction. So then we can calculate what is this contact force. So if we write the Newton's second law, that it, so we know that the in the direction of acceleration, this force is 14 Newton. So 14 minus this contact force, right? Contact force on A is due to B is this direction. So this is CB. And then we have mass of A, that is 4. And then acceleration is 2 that we have calculated. So then what is 14 and then minus 8, and then this is C. So how much is C? CB is 6 Newton. So this would be the contact force applied by B. Is it clear? We have to just use the free body diagram. Yes, is it clear?
Yes, sir.
Yeah, then please note it down. Right, so please note it down. But before you note it down, can you please tell me that why didn't we count this contact force due to A? Why didn't we count this force on A? Because we didn't count this contact force due to A. And you have to remember that in free body diagram, the answer is that in free body diagram, don't write the force which is applied by the object. So this CA is applied by the object. So that is why we don't count this force, right? So we only have three forces, A, CB, and 14. Those are the only forces that are there. Yeah, whenever you have noted, just if you have noted, just then we'll do the next question. And there are two, three more questions are left in this chapter, and then we'll move on to the next chapter. So from the next class, we'll talk about work energy and power. Whenever you have noted, just tell.
Done, sir.
Yeah. Okay, then let's do the next question. So we'll do this lift one, and then okay. So why this is okay? So we'll do this lift question, right? So we have a lift of mass of 1000 kg is moving upwards with an acceleration. So we have this lift. This is moving with this is of 1000 kg. So this will have the weight in this direction. So the weight would be 1000 mg. This is moving in upward direction with acceleration. So we have acceleration, and then we have tension due to string, right? So if we write the free body diagram of this thing, if we write, because this is moving, this has an acceleration. So if we write the Newton's second law, that would be how much? So this is in the direction we have tension, opposite to direction we have weight. Mass is how much? 1000. So then the tension would be how much? 1000 into A is 1 plus 1000 G is 10. Right, so this is how much? This is 1000 plus 10,000. So this would be 11,000 Newton. So this would be the tension. Right, so 11,000. This would be the option. Is it clear? If it is clear, quickly note it. Yeah, so quickly note this thing down, and then we'll do more questions and then we'll stop, right? In the next class, I will start this work energy. Noted. Yeah, is it noted?
Yes, sir. Done.
Yeah. And this question you can do, right? So these kind of question we have discussed. So this one you can do. So I will skip this part. Now, what do we have? So we have, yeah, these one are not so important. So these positions are very important. So this one and uh, okay, a car of Honda negotiates a bank of Road 92 is the banking and the speed of the car is good. So this is a direct question. This we will do. And yeah, so these are what is the exact this frictionless. If the banking angle is the speed of the car. Good. Okay, so yeah, these things I will I will do one more question from this one, and then I will talk about the bank road and all those things, right? But we don't have the vertical circle types. Vertical circle. Okay, a body of mass kept in the horizontal surface. So we have this thing, and horizontal force is applied on the body, but it does not move. So horizontal force is applied. It is not moving. It does not move. The resultant of normal reaction and the frictional force acting on the object is given F, where F is out. Right. So we have this thing, which is the friction, and then we have this normal reaction. So we have to find out, right? We have to find out the resultant of normal reaction and the frictional force on the object is what? So that is F, right? So let's say that this is the resultant, and both 90 degrees. So let's say this is F, and this is some other F, F prime. Right. So what would be this resultant? This would be simply how much n square plus f square. This would be resultant, right? So this would be how much? This is n square, and then this is mu s, and n, which is mg, right? So this is square, and we know that this is n square. So we can take out. We can yeah, we can just this. So we can write this as so this is mu s and n square. And now this is n square, this is n square, so we can take it outside, and this would be outside of the root. And this would be 1 plus mu s, right? So this is v square, mu s square, right? And this is n, which is m. This would be 1 plus mu s, which they are calling as mu. So this is mu square. And we see that what is the option? That is the C option. So this would be the answer. Is it clear? Is this part clear? If it is clear, then quickly note this thing. Right, so quickly note this thing down. So you will have direct questions in the chapters, right? The direct question, they will not take that much of time. So yeah, if it is clear, then quickly note this thing down, and then there are two questions more, so I'll stop there. Those two questions will be the next time. You just have to remember the back road condition, right? So those two questions that I'll talk about. Whenever you have noted them, and please, whenever you have any doubt, please don't hesitate to ask me, right? Otherwise, the doubt would be there with you authors. Whenever you have any doubt, please tell me. Yes, noted. But done. Okay, so we'll stop here and then see you in the next one, right? So we'll stop. Allah Hafiz, Adil. Now,
Love you, sir. Thank you.
bye, bye, Allah Hafiz.